Welcome to Science Store online classes.
Don't forget to like our video and subscribe our YouTube channel for all the updates.
So before moving into the next problem, that will be the last problem of our numerical sum in this chapter. Okay. Before going to that, I am going to discuss some of the topics of mathematics. That is, we are going to talk about differentiation, how we are going to use in physics. We always discussed, we already discussed, that is acceleration time graph. See, position time graph we have discussed, velocity time graph we have discussed. Now acceleration time graph is nothing but acceleration along y axis, time is along x axis. Acceleration is along y axis, time is along x axis. That is the thing. Now what happens? You have to find out here. That is the thing. So area under acceleration time graph gives a change in velocity. Area under acceleration time graph gives a change in velocity. Now that is one term I wanted to tell you. Now we are going to talk about differentiation. So what is that differentiation? How we are going to use? How we are going to use in physics? That's all we are going to talk about. Before that, I want to tell this. See, we have discussed about instantaneous velocity, right? So what do you mean by instantaneous velocity? Instantaneous velocity means, say some distance is there here. A person is running, from point A to point B. From point A to point B, whatever it may be the distance. Now what is going to happen? Somewhere at this distance, what was velocity? See, first becomes 0. It is increasing, running very fastly, increases means somewhere it reaches means some velocity it was there. Now my point is there, when it reaches at this point O, at that instant, what was the velocity? Can you find out practically? No, practically we can't find out. For that whole process is needed. For that whole process of this A to B is needed and necessary. For whole process of A to B is needed and necessary. So for that what we will do? I will write down the graph. Since velocity is increasing, displacement by time, if I write down, velocity from position was 0, velocity goes on increasing like that. Now when he reaches at this particular point, say for example this particular point, what is the velocity? That becomes instantaneous velocity. That becomes instantaneous velocity. How to find out that instantaneous velocity? It is very difficult at that instant. For that what we will do? We will take some of the points here and some of the interval here. Say for example it is 1, 2, 3, 4, 5, 6, 7, 8, 9. Now what happens? At this point and this point, if you consider means, I can draw the slope and I can find out the velocity. But slope you are not going to draw in this way, slope will be in this way, isn't it? That is what we are going to draw. Differentiation means is nothing but like a slope only. At that particular point you have to draw the slope. But what we are going to do? We are going to divide it. So in instantaneous velocity means what? Instantaneous velocity is nothing but, the limit of average velocity with respect to time, as the time interval delta t becomes 0, as the time interval delta t becomes 0, as the time interval delta t becomes 0, isn't it? As the time interval delta t tends to become 0. Now what is going to happen? Increases, 3.1, 3.2, 3.4. Now time interval I have to reduce. First it was how much? 9 minus 3, 6. Okay, now 9.2, I will decrease here. This becomes what? 8.9. I will increase here. That is nothing but 3.1. Okay, now it becomes 5.8. Okay, similarly I will decrease, I will decrease, I will decrease, I will decrease, I will divide. When I am going to reach this point, that small it going to become, no. So 5.8, I have 5.2, it becomes after that 4.8, 4.6, 4.4, if you divide like this means, okay, finally you will reach your desired point, no. Means what you have done, you have divided and finally you are reaching here, means whole process you have done, no. So if you divide, that means finally what we will get, this length, okay, this division was in this way, it is going to reduce in this way, it is going to reduce in this way. Finally what happens, it comes this point. So there you have to draw the slope. There you have to draw the slope and you have to find out the instantaneous velocity. Slope means what? Slope means x by y, no? Sorry, here x by t it is, sorry. But actually slope is nothing but y axis divided by x axis. But here y axis is nothing but x axis is nothing but time axis. Okay, in physics. So that is what instantaneous velocity we are going to get, no? By dividing at particular instant. And that what, how you are going to write down? The instantaneous velocity you are going to write down, that is limit of, okay, average velocity as the time interval delta t becomes infinitesimally small, which is nothing but dx by dt, the smallest velocity, smallest interval. What was the velocity? The smallest interval, what is the displacement and what is the velocity? No, in the smallest interval, in 1 second, 3 steps he may take. We don't know. At the first, what happens? 1 step in the 1 second. Second, it faster. So you will reach certain velocity here in such a way that in 1 second, 3 steps may he take. We don't know actually what is the distance. So whole process we have done. Then we have divided. What was that one instant? Though it is 4.1, that actual instant is 1 second. 4.1 to 4.2 or less than that of 1 second, we don't know. At that particular instant, what was the total displacement, so that we have to find out the velocity in the smallest instant. So what we have to do for that? For that we have to draw the slope for that line and we have to do the differentiation. We have to take the variation of x with respect to t. We have to take the variation of x with respect to mathematically we have to do. Physically we can't count. Okay, we can't find out. Mathematically whole process you have to consider. After that you have to write down the equations and in the form of equation you have to do. So that is what nothing but the differentiation. Then what are the formulas? All the derivations of formulas you will get in mathematics. Generally how we have to use this in physics, that we are going to discuss today. Say for example, now what we have studied, what do you mean by uniform motion? Uniform motion means as the time interval increases, same way the distance is going to increase or displacement is going to increase. What we will do? We will writing for the uniform motion xt graph in this way. But is it necessary to write down xt graph x in this way? No, uniform motion, no need to write down the graph and you have to explain. Now we have equation, mathematical equation I can write down. If I write down, at the place of this graph, if I write down x is equal to t means, you will make out 1 second 1 meter, next 1 second, next 1 meter, next 1 second 1 meter, next 1 second 1 meter, like that you will say, no, because x is equal to t, that is uniform motion, isn't it? Okay, in this way you can write down. So you can write down in any way, x is equal to t square for the different x is equal to 2 plus t. So in the form of equation now you can represent the motion of the object. See, first we studied about motion of the object we are representing by using different quantities. After that we wrote some graphs. After that we arrived kinematic equation. Now in any equation if you represent means you will get the kind of motion, no? That is what. So with respect to x you are going to write down, with respect to time you are going to write down. Now I am going to write down x is equal to t. Okay, x is equal to t means this is a uniform motion, this is a uniform motion. Now what is the instantaneous velocity? Instantaneous velocity is nothing but dx by dt. Okay, instantaneous velocity. Instantaneous acceleration is nothing but dv by dt. Okay, dv by dt. Formulas are for all same. Now what happens? X is equal to t means dx by dt, which is equal to dt by dt, which is equal to 1. Okay, in this way. If suppose x is equal to t to the power n, x is equal to t to the power n, then what happens? Instantaneous velocity at t is equal to 1 second, they will ask. What do you have to do? So dx by dt, at the place of dx, t to the power n is there, dt, its formula is n into t to the power n minus 1. N into t to the power n minus 1. I will give the example for this. I will give the example for this. Say for example, x is equal to t to the power n is general. Here it is t to the power 3. X is equal to t to the power 3. What do you have to do? Dx by dt. Okay, which is equal to, at the place of x, t to the power 3 is there. No, t to the power 3 is there. N into t to the power n minus 1. N means how much? 3. T. 3 minus 1 is 2. So 3t square it becomes. Similarly, if I give x is equal to t to the power 5, how much? That is dx by dt, which is equal to 5 into t to the power 4. Similarly, if I give x to the power 18, how much? That is nothing but dx by dt, which is equal to 18 t to the power 17. Okay, like that. So t by, so x is equal to, if I give x to the power 7, whatever it may be, 7 means dx by dt, which is equal to 7x to the power 6. In this way, these are the examples for this formula. This is important. One formula, this is one more formula. Now what happens? This is only based on t they have given, only based on t. I will erase this. Now what they will give, what we will be having is, we can have x is equal to k into t to the power n. K means some constant. When I will give the examples, you will understand it. Okay. So now dx by dt means how much? At the place of t, k into t to the power n divided by dt, which was k into k. K is multiplied. K you can't differentiate k. Okay, so k you have to take it out, and after that you have to write down k into t to the power n dt, which is equal to k will be here n into t to the power n minus 1 in this way. N into t to the power n minus 1 in this way. Okay, like that it is. So x is equal to, now I will give you example, 5t to the power 4. 5t to the power 4. 5 you have to take it out, that is dx by dt, which is equal to 5 you have to write down. T to the power 4 means that you have to do in this way, that is 4 into t to the power 4 minus 1 is 3. So it becomes 20t3. Okay, now I can give one more problem, one more example, that is nothing but, okay, 3t to the power 1, 3t to the power 2. Okay, it will be dx by dt, which is equal to 3 will be same only, 2 into t to the power 2 minus 1 is 1. So 60, like that it goes. So this is one more formula, that is for this, if it is you are going to get in this way. Now what do you mean by, what is the velocity of this object which is at rest? The object which is at rest means you are going to write down the graph xt is in this way. What is the velocity of the object which is at rest? Yes? Think. Constant? 0, right? The object is at rest means velocity is not there, that is 0. If the velocity is 0 means object is rest means this object is with respect to the corner, with respect to me, or with respect to some object is here, with respect to this object, that board is at rest. The distance remains same, no? What will be the velocity? Velocity is 0, no? Okay, so distance is constant, or some constant you are going to get means, What is the differentiation? Differentiation of that is 0. So t is equal to k. Okay. So dt by dt, which is equal to, x is equal to k. X is equal to k. So dx by dt. So it is a constant value 0. So x is equal to 5 means how much? Dx by dt, which is equal to 0. X is equal to 8 means how much? Dx by dt is equal to 0. It is not only for 5 or 8, okay. See, here multiplied. Now term is not there, variable is not there here, no. So what happens? Whatever may be the constant, it is not only for 5 and 8, or think that 5 and 8 we will write down 0. No, it is not like x is equal to whatever may be the number comes. X is equal to whatever separate number comes, no, dx by dt will be 0. Okay, dx by dt will be 0. These are the things I wanted to tell you. These are the formulas. Okay, so again, what is the x is equal to sine t if they are given? Sin t means sin theta cos theta, tan theta at the place of theta, t is there. Okay, then dx by dt is nothing but sin means cos t. So x is equal to cos t they have given means dx by dt is minus sin t. Sin t is cos t is minus sin t, like that. Okay, then so this is enough, this is sufficient. This problem formulas you have to go through it. Next, how to find out velocity? See, I will tell you, velocity is nothing but dx by dt, isn't it? Acceleration is nothing but dv by dt. V means what? V means dx by dt, no? Means what you are going to write down? Square times dt square, d square x of dt square. With respect to dt, 2 times you have differentiated. This is single time you have differentiated. Now I will give you an example based on this. Okay, if x is equal to 3t square, find velocity and acceleration. Find velocity and acceleration, but displacement is given. Displacement varies with 3t square. Displacement varies with 3t square or 1t square. I will tell you. 1t square means how it will be. Graph if you write down means x is equal to 1 means t is equal to 1 means x is equal to 1. T is equal to 2 means x is equal to 4. T is equal to 3 means x is equal to 9. 3 is equal to 4 means x is equal to 16. In the straight line graph it goes, no? Okay, then what is the velocity? Graph will be that graph only we have written in the form of equation, no? Okay, you know to write down the graph. See, you have writing the graph x and t, you will give the values in your lower classes. You have studied, writing the graph, and that is what it is given. Now we are not writing any graph because we have equations, that is sufficient for us. It is not needed that to write down the graph and understand. No, everything in the form of equation we can understand. No, that is the simplicity what we have done. Right, now what I have to do? Displacement they have given. Displacement is t square, square of the time. What is velocity? What do you have to find out velocity? Velocity, I know that. Velocity is equal to dx by dt, right? Velocity is equal to dx by dt. So velocity is equal to dx by dt, which is equal to t square by dt. T square by dt, which is equal to 2 times t to the power 2 minus 1, that is 1. 2 times t to the power 2 minus 1, that is 1, like this. Then what is the acceleration? Acceleration is equal to dv by dt. So velocity is equal to 2 times t you got. No, dv by dt means what? So at the place of 2t v you have to put 2 times t dt. 2 times t means it is in the form of kt to the power 1. T to the power 1 is there. So what you have to do? 2 into d to the power 1 by dt. You have to write down. D to the power dt by dt is 1, no. T to the power 0, isn't it? 1 into t to the power 1 minus 1, that is 0. So it is 1, no. So you are going to get 2 meter per second square. Acceleration of the object is 2 meter per second square. Simple. You got from the equations, no? No need to write down any graph, no need to find out any slope, nothing. Using mathematical formulas we are doing, that is the application of mathematics in physics. Okay, we are doing. Now they will ask you, see, x is equal to t square. Find out the velocity at t is equal to 2 seconds. Earlier I said no, instantaneous velocity. Now 4.1 second it becomes, that time we have to find out the velocity. Instantaneous velocity means, see, 1 second, 2 second, 3 second, 4 second, till 10 second a person will run. Now I will ask you exactly at 4.1 second what is the velocity. Can you find out immediately? No. Throughout the process you have to calculate, you have to draw the graph, you have to find out the slope. Is it necessary now? No. You have to write down the equation, that's all. If you write down the equation, what happens? If you do mathematical formulas, mathematical equation, simple. Everything is solved. Now what I was asking? Yes, find out the velocity of that object when t is equal to 2 seconds. How we have to find out? Velocity I know. Velocity is equal to 2 into t. Where is? So v at t is equal to 2 second, how much? 2 into 2, that is nothing but 4 meter per second. Meter per second. At velocity is equal to 2 seconds, what was its velocity? 4 meter per second. That is the velocity, no? That is the velocity. This is what the problem. So based on this one more problem we are going to discuss. Okay. So one more problem we are discussing. The displacement of the particle moving along x-axis is given by x is equal to 18t plus 5t square. You have to find out instantaneous velocity at t is equal to 2 seconds. You have to find out the average velocity and you have to find out the instantaneous acceleration. We are going to find out the first answer. Okay. So what is that? Instantaneous velocity at t is equal to 2 seconds. We have given x is equal to 18t plus 5t square. Along with me do it. Okay. Now dx by dt how much? Dx by dt is nothing but instantaneous velocity. Velocity is nothing but how much? 18t. Okay. So 18t means what you have to do? Dx by dt you have to write down, no? So d at the place of 18t by dt plus d of 5t square by dt. So what happens? It is 18 into dt by dt is plus then 5 into dt square by dt, that is nothing but 2 into t to the power 1, that becomes 18 plus 10t, that is velocity, actually instantaneous velocity. But what is the question? Question they have asked that instantaneous velocity at t is equal to 2 seconds, no? So what you are going to do? 18 plus 10 into 2, that is nothing but 20 and 30, 38 meter per second. That is instantaneous velocity. Next what you have to find out? Average velocity between t is equal to 2 seconds and 3 is equal to 3 seconds. Okay. Average velocity means what? Average velocity, you have written x2 minus x1 divided by t2 minus t1, which is equal to delta x by delta t, you have written. So here t2 is 3, t1 is 2. So x2 you are going to find out. X at 3 seconds. X at 3 seconds. What is that? 3 seconds means 18 into 3 plus 5 into 9, isn't it? Okay, 5 into 9 because 3 square it is. Okay, so it is 54 plus it is 45. How much you are going to get? 9 and 9, 99 meters you are going to get. Next what you are going to get? X at 2 seconds, that is nothing but 18 into 2 plus 5 into 4. Okay, what you are going to get? So 18 twos are 36 plus 20, 30, 40, 50, 56 you are going to get, isn't it? 56 you are going to get. Now average velocity will be how much? Average velocity x2 minus x1. x2 means here it is actually this. So x3 seconds minus x2 seconds divided by 3 minus 2. No, time interval. So x3 is how much? 99 minus 56 divided by 3 minus 2 is 1, which is equal to how much? Okay. That is 3 and 4, 1, which is equal to 43 meter per second. 43 meter per second. 43 meter per second. You are going to get. Next. That is instantaneous acceleration. Instantaneous acceleration means how you have to find out. You must know instantaneous velocity. Instantaneous acceleration is dv by dt, isn't it? Instantaneous acceleration is dv by dt. I'll erase this. You must write down. Okay. So instantaneous acceleration is how much? Instantaneous acceleration is a is equal to dv by dt. So what is v? V we know, that is 18 plus 10t. 18 plus 10t. So acceleration is equal to dv by dt, which is equal to d. At the place of v, at what is there? 18 plus 10t is there, divided by dt. Separately you have to write down d of 18 by dt plus d of 10t by dt, isn't it? What you are going to get? Constant. No, whatever the constant is there, whose value you have to write down 0. Plus here 10 is multiplied with the t. So 10 into dt by dt, which is equal to 10 meter per second square. This is nothing but instantaneous acceleration. This is nothing but instantaneous acceleration of the body. Okay, this is what I can say, and here we are going to conclude about motion in a straight line. What actually we have studied? Motion in a straight line means, till from the beginning, if I say, according to NCERT, till from the beginning we have studied path length, displacement, average speed, average velocity, acceleration, position, time graphs. The area under velocity time graph gives displacement, and kinematic equations, and slope of the position time graph gives velocity, slope of the velocity time graph gives acceleration, area under acceleration time graph gives change in velocity, and after that equations, kinematic equation, that is x is equal to vt plus half at square, v is equal to v naught t plus v is equal to v naught plus at, and v square is equal to v naught square plus 2ax. These equations we have studied, and after that free fall, reaction time, stopping distance, relative velocity. Those things we have studied, and after that, in that the numerical sums we have discussed, the numerical sums we have derived, right? We have discussed. So that is also important for us. Go through once again all the topics, neatly understand, go through it once again and again, study it, and after that, whatever the board things I am going to write down, you must write down in your notebook, so that you can understand in a better way. So these are the numerical sums we have discussed. Now hereby we are going to conclude motion in a straight line. Okay, so next we are going to move to the next topic and next chapter. Okay, that will be motion in a plane. Okay, we are going to talk about that in our next video. Thank you very much.
Don't forget to like our video and subscribe our YouTube channel for all the updates.